My name is Mathias Buente. I would like to welcome all of you to this talk and thanks very much to the organizing team of the Things conference for inviting me as a speaker. I'm working for BOPLA Enclosure Systems, one of the world's leading brands in the field of enclosures for electronic devices and HMI solutions. In my role as a business development manager, I do come across the topics of this talk on a daily basis, and I would like to share a little bit of the know-how with you. The topic of my talk today is boxes for IoT. This might sound a little bit strange to many of you, and amongst all the typical IoT related buzzwords that you will come across during this conference, you might have asked yourself, boxes? Why did they reserve 15 minutes of conference time for something trivial like a brick-shaped piece of mechanics? Well, during this talk you will notice that boxes and IoT have more in common than you would have expected prior to joining. I've tried to set up a few equations in order to build a solid bridge between electronic hardware and software and mechanics. Let's see if it works. IoT. That's data acquisition and communication everywhere. Everywhere, that's heat, that's frost, water, dust, chemicals, UV, impact, pressure, lots of challenging environmental conditions. And an IoT means high-end hardware and software plus protection against all these environmental conditions. And protection, that's a box, and that's an integral feature of your IoT device. The most obvious features of a box are its length, width and height. And that's in fact one of the initial considerations you have to make when choosing the right one for your application. But as we are not talking about cardboard boxes here, by the way, that's the last chance for the logistics people and forwarders in the audience to leave the talk, there are way more things to consider. For this reason, we will switch from boxes to enclosures now and start digging into details. As you can spot in this nice practical example with the batteries, the enclosure is an integral part of your IoT project, and you should take care of it right from the start of your project. At a certain stage of your project, you will come across an important question. Where do I put my PCB? You might launch your 3D printer, browse the catalogs of the enclosure specialists, maybe BOPLAs, or think about a custom tool right from the start. I've tried to compile the most important aspects and considerations in this chart. Lead times and pricing indications are based on our long-term experience. There may be, of course, lots of speeders or price breakers out there, but I would like to stay on the realistic side here. A custom tool is, of course, the optimum way to create a tailor-made enclosure, but for many of the startups in the audience, maybe not the optimum choice due to the investment and the time it takes in order to have your enclosure ready on the desk. A customized standard is always, in any case, a rock-solid choice. Maybe some of you would strongly disagree, but as an enclosure specialist, we wouldn't rate 3D printing being a suitable volume production technology at this stage. Something like that would be a pretty cool enclosure compared to all that brick-shaped stuff out there in the market, right? 3D printing offers design freedom and unlimited possibilities, but unfortunately, part design does not correspond with the restrictions of the typical volume production technologies, like plastic injection molding, die cast, profile extrusion, sheet metal, blow molding, and many others. It's unfortunately a quite common scenario in our business that we need to shatter our customers' dreams when a project goes to volume production. For this reason, always keep serial production in mind. Plastic or metal? That's an easy choice when it comes to an IoT device with an internal antenna, and if you want to avoid the costly integration of RF transmissive areas into a metal enclosure. There are also good reasons, for example heat dissipation, for choosing a metal enclosure. Some of you might even think that metal is the primary choice when it comes to real tough environments, but that's not necessarily true. There are lots of high-performance plastic materials available which are suitable for use in the most challenging environments. We will cover some important aspects of plastic materials further down this talk, but back to design-related aspects first. The IP rating is part of the Enclosure ABC, but even the long-term experts in my team sometimes require some extra lessons here. The IP rating according to EN 6529 is a 2-digit code. The first digit indicates the protection against the ingress of solid materials and dust, but also the protection for the operator against electric shock. The second digit indicates the protection against water. Very important, water at room temperature under laboratory conditions. No seawater, biological liquids, oil, solvents, etc., etc. The higher the number, the better is also a common misunderstanding. IPX7 or X8 do not automatically cover the X0 to X6 ratings. And IPX9 is related to high pressure cleaning with hot water and does nothing have in common with the rest of the testing procedures. Make sure to match the IP rating with the true requirements of your IoT device in order to save money. Enclosure with a high IP rating flooded. Time for quality complaints and claims for compensation in this case. Go back to the manufacturer. Unfortunately, this equation is not that simple, and one important little component might be missing in your enclosure concept. The IP rating of an application, respectively an enclosure, is being tested under laboratory conditions at room temperature. Temperature variations will shrink and expand the body of air inside the enclosure. This might create a temporary vacuum. And high IP rating plus humidity plus temperature variations might result in condensation of water inside your enclosure. And enclosures with a high IP rating are subjected to the highest risk here. Always consider the integration of a pressure compensation device into an outdoor device. I would like to keep impact protection a little bit shorter here, as time is limited for our talk. The impact energy that an enclosure needs to survive without functional damage is indicated in 10 so-called IK ratings. It is pretty obvious that this is related to part design, material, and accessories applied. And of course, with corresponding costs involved. Part design and material. Right on the cue, we will return to plastics now. It is pretty obvious that flammability is not an issue with the metal enclosure involved. But relevant product standards for electronic devices put a focus on this important topic. In order to keep the pace with the conference schedule, I've tried to summarize the testing procedures according to UL94 material testing in a little uncommon way. It's winter time and some of you might have a fireplace at home, right? Material we are talking about is wood. What burns faster? A thick log or a thin sheet of paper? Well, that's obvious, I guess. What burns faster? A matchstick in horizontal or vertical position? Okay, seems that you have passed this little quiz. In UL94 material testing, it's pretty much the same. A material that has passed the material test under more critical conditions does have a higher flammability rating. If you want to design a plastic enclosure with a certain flammability rating, you have to match the wall thickness with the material test results listed in the material datasheet, respectively the UL test report, which is called yellow card. Which plastic material is suitable for outdoor applications? Well, there are lots of manufacturers' declarations out there in the market stating that the material, respectively the enclosure, is perfectly suitable for use in an outdoor environment. If you want to stay on the scientific side with material tests and data sheets here as well, UL standard 746C is the applicable one. The plastic material, with all its properties, is being subjected to a severe weathering test with 1K hours of CNN UV exposure and 7 days of water immersion at 70 degrees Celsius. Indices F1 or F2 represent the full or partial exposure testing. On top of flammability and outdoor rating, you might come across some more detailed questions and considerations with regards to plastic materials. 99%, approximately, of the relevant information, including important UL test results, are listed in the datasheet of the ground plastic material, the so-called resin. Additional declarations and application-specific test reports may be obtained from the resin manufacturer for selected materials. Okay, I guess we should stop here, as otherwise we might have to rename this conference into the Box Conference, and I don't want to do that. Let me summarize our enclosure talk based on a typical product from BOPLA's range of standard enclosures now. In the last slide of my presentation, you can spot most of the topics that we have touched during this talk at a glance. In order to achieve an IP65 rating, we require an optional gasket here, which does of course have additional costs involved. Pressure compensation can be integrated in an easy and convenient way. Global considerations on investment, availability, and production are focusing on the standard, respectively the customized standard solution in this case. And material-related topics like suitability for railway applications, outdoor applications, and the flammability rating may be obtained from the material data sheets, respectively material manufacturers' declarations. So as a final summary, make all design, material, and production-related parameters match your application perfectly in order to create the optimum enclosure solution for your application. And this is maybe the most important thing, keep an eye on the enclosure at an early stage of your project already. I hope you have enjoyed this little excursion into the world of enclosures. Enjoy the rest of the conference. Stay healthy and safe in crazy times. Goodbye. Thank you very much.